Let's talk about how to balance redox equations using the half reaction method in basic solution. We can balance redox equations in acidic solution or in basic solution. And a question will always say, balance this in acidic solution or balance this in basic solution. So that's how you'll know which method to use. Doing this in basic solution just means that we're going to be adding OH minuses here to help balance the atoms. And that's because OH minus, hydroxide, makes things more basic, okay? Now, the process for balancing in basic solution is really similar to the process for balancing in acidic solution, except the process for balancing in basic solution has a couple extra steps at the end. In this video, I'm going to go through one basic solution problem from start to finish so you can see all the steps and you don't need any prior knowledge about redox balancing. Now, if you're already a rock star at balancing redox equations in acidic solutions, feel free to skip through most of this video and just focus on the end part where you'll see some extra steps used for balancing in basic solution that you don't use for balancing in acidic solution. Got it? Let's get started. This is the equation that we're going to be balancing, and we're going to start just like we do with acidic solution by determining the oxidation numbers of the elements in the equation. Okay, so starting here, Zn, zinc, is an element by itself. It's not combined with any other elements, so it has an oxidation number of 0. NO3 is a polyatomic ion. We don't know what nitrogen's oxidation number is, so we'll have to figure it out. Oxygen's is usually -2. We have 3 oxygens here, so we'll do -2 times 3 gives us -6. Now, whatever nitrogen's oxidation number is has to add with -6 to make -1, because that's a charge on this polyatomic ion, and all of the oxidation numbers have to add up to this charge. So, nitrogen's oxidation number is going to be +5. +5 minus 6 equals -1, so +5 for nitrogen over here on this side of the equation. Now over here on this side, zinc has become a monatomic ion with a charge of 2+. So its oxidation number is just going to be the same as its ionic charge. Okay, so +2 is zinc's oxidation number on this side. And then we got the same thing here with nitrogen. We got to figure out what it is. Okay, oxygen is going to be -2. We have 2 oxygens, so -2 times 2 gives us a total of -4. NO2 here is a neutral compound though. So nitrogens and oxygens' oxidation numbers are going to add to 0. So that means that nitrogen's is going to be +4. +4 minus 4 equals 0. So +4 for nitrogen on this side of the equation. So what's being oxidized and what's being reduced? We'll look at changes in oxidation number. Okay, zinc here is 0 on the left side of the equation, and then it's +2 on the right side of the equation. So zinc's oxidation number is going up, which means that it is undergoing oxidation. So zinc here is oxidized from 0 up to +2. Nitrogen here is +5 on this side, and then it's +4 on this side. So its oxidation number is going down. It is undergoing reduction. Nitrogen is getting reduced from +5 to +4. Oxygen is on both sides of the equation. It's -2 here and -2 here, so it's neither oxidized nor reduced, so we don't have to worry about it at all. So zinc is oxidized, nitrogen is reduced. Now let's write some half reactions for the oxidation and the reduction. The oxidation half reaction is going to look like zinc, Zn, and then Zn2+ on the right side. Nitrogen is getting reduced, so on the left side of the reduction half reaction is going to be NO3, 1-. Then we got the arrow, and then the right side, NO2. Okay, now let's balance each one of these. We'll start by balancing the reduction half reaction. What's this on my finger? Got some marker on the finger. It's an occupational hazard. Sometimes I'll go out with my friends in the evenings and they'll be like, "You were doing a video today, right?" And I'll be like, "How did you know?" And it's because my hands are just covered with marker. Anyway, we're going to balance the reduction half reaction. We have two elements right now, nitrogen and oxygen. Okay, so on this side we have one nitrogen, we have O3, we have 3 oxygens. Then on this side we have one nitrogen and we have O2, we have 2 oxygens. So our first step is to balance the atoms other than oxygen and hydrogen. That would be nitrogen here, and we're all set. We have one nitrogen on this side and one nitrogen on this side. So let's move on to the next step here. Add H2O to balance O and H plus to balance H. Okay, so right now let's focus in on oxygen. There's an imbalance in the number of oxygens. We have 3 on this side and we have 2 on this side. So I need to add more oxygens to this side, okay? So I'm going to add H2O here. Now, how many H2Os do I want? Each H2O molecule has 1 oxygen atom. I have 2. I need 3 so they balance. So all I need is 1 oxygen atom. Okay, so by adding just 1 H2O, I get that 1 oxygen I need, so I can go from 2 to 3 on this side. Okay, all set. Nitrogens and oxygens balance, but by adding this H2O, I introduced a new element into the equation, and that's hydrogen. Okay, so now we gotta put that in here. Okay, H2, there are 2 hydrogens in H2O, so I got 2 on this side. Right now I have 0 on this side. Okay, so that's a problem. But I can balance out my hydrogens by adding H plus. Okay, so here's my H plus. How many H pluses do I need? I have 2 hydrogens on this side, so I'm going to make 2 H pluses on this side, so now that's going to give me 2 hydrogens here on the left. Now real quick about these H pluses. Adding H pluses to something makes it more acidic. We're supposed to be balancing this equation in basic solution, but we're going to worry about the basic part later. Okay, so right now we add the H pluses, they temporarily make it acidic, but then in some of the end steps, we add additional OH minuses to cancel out the H plus. So don't worry about this for right now, even though it does make the equation acidic. Okay, so the atoms all balance, nitrogen, oxygen, and hydrogen. The last thing that we want to do for the reduction half reaction here is to balance the charges by adding electrons. So let's take a look at the charge situation in the equation. Okay? On the left side, we have 2H plus, so that's going to be plus 2. And then we have 1 NO3, 1 minus, so that's going to be minus 1. Plus 2 minus 1 equals plus 1. And then here on the right side, we don't have anything that's charged, so we just have a charge of 0. Okay? So what I need to do in order to balance these is to lower the charge on the left side here, and I can do that by adding 1 electron. Here it is, E minus. This electron has 1 negative charge, so adding to the left side, plus 1 minus 1 for that 1 electron gives me 0. Now I got 0 on this side. Let's line that up. Now I got 0 on this side, and I got 0 on this side. The charges are balanced, the atoms are balanced, and now I'm going to move on and balance atoms and charges for the oxidation half reaction. Balancing the atoms for the oxidation half reaction is going to be pretty easy, because all I have is 1 element here, and I have 1 atom of each on both sides. 1 zinc here, 1 zinc here. So I don't have to worry about balancing the atoms other than oxygen and hydrogen, and I don't have to do any of this stuff with oxygen and hydrogen because I don't have those. So I can skip right ahead to adding electrons to balance the charges. We are going to have to do this. Let's take a look at the charge here. On this side, I don't have anything that's charged, so I have 0 charge. And then over here, I have 1 Zn2 plus, so I have plus 2 of charge here. In order to get these to balance, I got to lower this side by 2. So I'm going to add 2 E minus, 2 electrons that have a negative charge. So I'm going to have plus 2 minus 2 gives me 0. Now I got 0 charge on both sides, and these charges balance. Now I'm going to start to put the oxidation and reduction half reactions together. But in order to do that, I've got to have the same number of electrons in both of them. And right now, I don't have that. I've got 2 electrons up here, and I have 1 electron down here. So to change that, I'm going to multiply this whole reduction half reaction by 2. just kind of like it's a math equation. Okay, so now I've got 2 times all of this. I'm going to distribute the 2 across this reaction. Okay, so 2 times E minus is going to give me 2 electrons. Perfect. Now the electrons are the same in both. Okay, 2 electrons plus 2 times 2H plus is going to be 4H plus 2 times that is 2NO3, 1 minus. Then we got the arrow, 2 times NO2, 2NO2, plus 2 times H2O, 2H2O. Okay, so now the electrons are equal, and this is my new reduction half reaction. So now that they have the same number of electrons, I can add them together. I'll add them together and then cancel stuff out that appears on both sides of the arrow. So let's do that. To add these together, I look at the arrow and I choose everything from both equations on the left side of that to start with. Okay, so left side, we start with Zn, and now I move down here for everything to the left of the arrow in this reaction. Zn plus 2 E minus plus 4H plus 2NO3, 1 minus. Then I have the arrow in both of them, so I put the arrow here. And now everything on the right side of the arrow for both the equations. So I have Zn2 plus plus 2E minus, and now down to here, plus 2NO2 plus, finally, 2H2O. A little bit of a tight squeeze. Plus 2H2O. Okay. Now, what I want to do is I want to cancel out stuff that appears on both sides of the arrow. And for this equation here, that is these 2 electrons. 2E minus here, 2E minus here. Okay? So get rid of those, and now when I rewrite this to get rid of the electrons, the equation is going to look like this. Just the same thing with everything else except for the electrons. So there it is for you. Now, if our goal was to balance this in acidic solution, we'd be all set. Everything balances now, and we're left with H pluses here, which make the equation acidic. But we've got to balance this in basic solution, which means that we're going to have to go through a couple more steps to get rid of these H pluses and replace them with OH minuses, which make things basic. So let's start to turn this into a basic equation. Here's the first step that we use only for balancing in basic solution. That's why I put this little basic above here. This is an extra step at the end if you're balancing in basic solution. Okay, as I said, we got to get rid of these H pluses because the H pluses make something acidic. So to get rid of these, for each H plus, add 1 OH minus to both sides. So I have 4 H pluses here. So to this side, I will add 4 OH minus, and then to this side, I will add 4 OH minus. Okay, the next thing that I'm going to do is I'm going to combine the H plus and OH minus to make H2O. So I have this H plus, or these H pluses, and these OH minuses. When H pluses and OH minuses come together, they make water. Okay, so here is the equation that we're going to get when we combine those to make water. You see on this side, I had the 4OH and the 4H plus, or I should say the 4OH minus and the 4H plus. They came together to make 4H2O. Okay? Nothing happened on this side because there weren't any H pluses for the OH minus to combine with. So the 4 OH minus are just sitting over here. Okay, so now our last step for basic solution here is that I'm going to subtract H2O from both sides if possible. Okay, think of this sort of like a math problem. Okay, I have H2O here and I have H2O here. So I can subtract something if it appears on both sides. So I have 2 H2O here 4 there. So I can do minus 2H2O, and that will cancel that out. I can do minus 2H2O, and that will leave me with 2H2O on this side, because 4 minus 2 is 2. So this will be my final equation. I have zinc plus 2H2O, because I subtracted 2 from here, plus 2NO3 minus gives me zinc 2 plus 2NO2. Then I subtracted away my water, my H2O from this side, so there's none left, plus 4OH minus. So I got rid of these H pluses, and I'm left with OH minuses, so this is going to be in basic solution. The last thing that I'm going to do is I'm going to do a final check to make sure that atoms and charge balance, just because I want to have the confidence that I did it correctly. All right, our final check. I discover mistakes all the time when I'm doing a final check of this kind of equation balancing, so I highly recommend that you do this too, just to make sure that your answer is right before you hand in your test or you hand in your homework or whatever. Okay, Zn, we have one of them. Hydrogen, 2 times 2, 4. Oxygen, I have 2 here, 2 plus 2 times 3, which is 6, gives me 8. And then I have nitrogen, I have 2 of them. Okay, over on this side, zinc, I have 1. Hydrogen, 4 times 1 from the OH minuses, so I got 4 hydrogens. Oxygen, I have 2 times 2, 4 plus the 4 oxygens here. 4 plus 4 equals 8. And nitrogen, 2 from the 2NO2. 1, 4, 8, 2. Awesome. The atoms balance. All right. Let's take a look at the charges on the two sides of the equation. Here I have no charge, 2 NO3 minus, so that's going to be minus 2 of charge here. And then I have Zn2 plus, so I have plus 2. And then I have 4 OH minus, so that's going to be minus 4, because I have 4 of these and they're each minus 1. Plus 2 minus 4 equals minus 2. Minus 2 here, minus 2 here, the charges balance. So I did everything right. So these are the steps for balancing a redox reaction in basic solution. Most of these steps are used for balancing in both acidic solution and basic solution, except for these 3 steps, which are used only for balancing in base. Balancing something in acidic solution gives us a bunch of H pluses, and so these steps for balancing in base use OH minus to get rid of those H pluses and then make it a basic solution.